actually, went into that work thinking we were going to find, differential dependencies in type 1 versus type 2 CALR mutant cells, which we did. But we did not anticipate the Bcl-2 versus Bcl-xL finding. So what we found is that type 1 CALR mutant cells activate pathways that lead to upregulation of and dependency on Bcl-2. Type 2 mutant CALR cells lead to upregulation of and dependency on Bcl-xL. And so we were really happy to find that, these pathways lead to clinically tractable, targets. And so what I talked about in my talk is sort of how we got there. How did we identify the pathways that led to us being able to differentially target type 1 versus type 2. So what we found is that although they have a shared gain of function binding to the thrombopoietin receptor and activating JAK-STAT signaling, they have differential losses of function. So type 1 CALR mutations cause loss of calcium binding function, type 2 cause loss of chaperone function, and that leads to activation of pathways, differential pathways in a type 1 versus type 2 cell that have multiple consequences, downstream, but one of those consequences was actually upregulation of different BH3 proteins that allowed us to differentially target the cells. So in addition to like venetoclax for type 1 or a Bcl-xL only inhibitor for type 2, like A133, 1852, which doesn't have a name yet, there are other, targetable pathways. For instance, there's an ER stress pathway called the IRE1-XBP1 pathway for which inhibitors exist. And people are developing more inhibitors for these. They're, sort of more in solid tumors, but obviously could be used in heme malignancies as well. And then we've also found in more recent work that these losses of function also affect like immune surveillance and cellular metabolism. So those are other, points of therapeutic intervention for which drugs exist that we can repurpose for inhibiting these pathways.